Welcome, everyone, to a new episode of the Recreate the Future podcast. We are still in season 1. Today I have Vegter with me, and today we're going to look very deeply into the topics of mass customization and design automation. So those might have been topics most of you probably haven't been in touch with. So I'm super happy today, Vegter, to have you on board and give us a bit of insight into this really crazy field of design. I'm really curious. So thanks for coming. And maybe first of all, you just want to briefly introduce yourself and trinckle as well.
Yes, thank you very much for having me. It's really an honor to be on the podcast, and the previous people you interviewed were very interesting as well. Actually, I was following Alice as well a little bit.
Okay, nice. Yeah, I think he's definitely very far in many of those topics, and I think mass customization might be relevant for him as well. So
it might be, yeah. But I'm just as a private person a big fan of what he does. So that was nice to hear him talk. Yes, so a little bit about me. I am Vegter van Sloten. I grew up in the Netherlands, studied industrial design there. And then I moved to Berlin. I worked a couple of years in a co-working space with a workshop there. And there when I studied industrial design, the 3D printing wasn't really a thing yet. But it started right after I finished my studies. And I got into 3D printing at the co-working space a little bit. I was giving some classes in design for 3D printing there, some workshops. And this is how I rolled into the 3D printing community. And then I started working at trinckle now 6 years ago, where I first managed the 3D printing service that we had. That was sold a couple of years ago, and now I am focusing on our software sites, and mainly I am focusing on finding people that want to try out our software as a third party, because we've been using it ourselves as a service.
Yeah. Maybe before we jump into the software, it's perfect that we have someone with your background here, because I think the best part is about understanding why design for additive manufacturing is so different than for other technologies like injection molding.
Yeah, that is indeed. I think the main reason for that is because the traditional way of designing is for mass production, and so you can the costs of a designer you can spread over many produced parts to basically where it's neglectable the cost of the designer. And this has been completely turned around in low volume or unique parts where this is getting problematic, and this is a real bottleneck, I think, for additive manufacturing.
Yeah, this is really interesting, because up to now, we also during the podcast, this has never been a topic, but I mean, it makes sense due to the fact that everybody says 3D printing is so great because you are able to have very low volumes. You don't have any tooling cost, so it's very efficient with a low number of items. But same for me, you never think about the design costs associated there.
Yeah, I think I mean it's super nice that now it's accessible to much more people, and people are getting into design themselves and try a little bit out, and that's all fine. But in a commercial setting, in a business setting, this is a problem.
Yeah. So you're right. So on the one side, within additive manufacturing, we have the benefit that the production cost itself, due to the lack of tooling, is way lower with low volumes. But at the same side, you can't divide the design cost through mass production. All right. Um, okay, so this is like the worst shift over to a new topic ever. But what could be a solution over there?
Yeah, so what we are trying to
Yeah.
do is mass customization and design automation, where we do the boring, tedious parts. We automate in the design process, so to enable designers to either either have the customers of the company design their own parts, or have the designers at the companies make time for the important designing parts, and not the little design tweaks that they may have to do.
Okay, so how can we imagine that? So I mean, like the traditional designing is, even for additive manufacturing, is quite similar with a CAD software. How does it work in your approach?
Yeah, so our own made CAD software that we have, TRCAD, is a script-based software. And some of the people in the 3D printing space may know OpenSCAD. It's not too. It is different from OpenSCAD, but it's not too different. So it's a script-based approach, and in this way, parametric design is much more potent, I would say.
Okay, but I'm not from the design space. I
Mm-hmm.
just saw the product based on your hackathon you did, which was really
Yeah.
cool. Um, so as a user, or from my perspective, from the outside, there are two steps. First of all, there's a step of the script-based version which I have to code, basically my application, and at the end of the day, I have a full. I have a very safe environment for novice users as well, where I can just with a graphical user interface explain what I want, and the software in the background creates the design. Correct?
Exactly. So that would be the second phase. So first you need the scripted CAD, or the product that you want to that you want to sell, or that you want to buy. That needs to be ready. But what we do is we open the parameters that the customer can customize themselves in a simple user interface that is web based. So you can in your browser go to a website and customize the product that you want to have to your needs.
So it's kind of like a design generator.
Maybe, yeah, you could say it's a design generator. Yeah, that's what automated design is. Yeah, so yeah, customers can customize their own product, press either download or buy in whatever case it is. So on one side we have the TRCAD, our CAD software, and then we have the API paramate that makes it available on a web page.
Okay.
On a web page, or on your phone, or anything with a screen.
So basically, this enables me as a novice, or basically uneducated user in that space, to basically generate my own design without the need for the scripting or coding, and on the other side, without the need to use any CAD software, because it's just like a graphical user interface, and I can just say what kind of settings I need, and you guys probably will then, based on the software, generate the design, right?
Exactly. Yeah, exactly like that.
Okay, cool. Because the problem is, whenever I try to explain it to people, also here in our company, I always had problems with really getting a grasp of it. But I think I now have to call it a design generator because this is what most people will easily understand. Okay, I think the best the the best part, because to my mind it's a really powerful concept and really powerful software. Maybe the best thing is to jump into some use cases.
Yeah.
So the one I saw was a rather like a medical application or use case. Maybe you can give us an overview of what is possible in the space of design automation.
Yeah, so one use case that we have is orthopedics. An example I'd like to give is a project we did with Protic, where actually 3D printing is not always the end product. In this case, it isn't, but the 3D printed part is the tool that is used by the shoemaker to make custom shoes for clients that have a need for special shoes.
So like orthopedic shoes.
Orthopedic shoes,
Okay.
indeed, yeah. So what we can do is we take the scan of the 3D scan of a customer, and it automatically morphs to this scan, and with a push of a button, basically, the tool is made. The orthopedic technician can still do the tweaks that he needs to do, but we enable him to skip the tedious parts where the repetitive tasks that he needs to do in this case.
And the benefit at the end of the day because the client or like the user of it is the people at the orthopedic shoemaker, right?
Yes, in this case, yes. That is an internal app that the orthopedic technician can use.
Nice. And now I get what you mean with with the design cost, because probably in that case it would take much longer to do the design manually.
Yeah.
Than to do it automatically with your software. And in this case, it also means the input variables are not like based on a graphic user interface and parameters, but also the 3D scan data.
Exactly. Well, we call that the open parameter as well. But yes, indeed, you can upload a mesh file. In this case, the foot of the customer, at the scan, and it automatically makes the design for you.
Okay. Crazy, because of course, if you think about like the decrease in design cost for that is significant, especially because I would assume that that it would be very difficult, especially today, to find people who are in that space and who are also be capable of the design aspect in that. And at the end of the day, the benefit for the patient is that they will get a more like better quality or better fitted product because it's more customized towards their foot.
Yes, of course. Yeah, so that depends a little bit on the quality of the 3D scan, I guess, but that's that is I have to say that's a part that's outside of what we do for software. So we only take the 3D scan as good as it is, and then it goes into our software.
Just as a side question about the 3D scanning. I know this is not like your focus, but we have been looking into that, I think like 2 years ago or something like that. And then it was, there were still those very pricey products. And at the same time, the first people started with like handheld scanners and some people even with their phones. How far is the industry in that part already?
Yeah, so I'm not an expert on that, but I do see that the quality of 3D scans in the last 5 years have been a lot better. And maybe, I'm not sure if it is in part of phones being so capable nowadays, but there's a lot happening in that industry, indeed.
Okay, really, really interesting. I still have to, I have a to do somewhere really down in my to do list that I still need to look.
I think in our company, there's also something on our to-do list, like see what the 3D scanning is doing.
Yeah,
It's very interesting indeed.
okay, cool. So I think that's a really nice, like a very hands-on example on how to use design automation, and this is really like mass customization because it's customized to the foot. I think maybe to get a bigger picture or like a more detailed picture, the other example I saw and I thought was really interesting was the robotic arm case from the rather industrial side. Maybe you can give us an some kind of introduction about how this technology can also not be on a patient level, but also like on an industrial level inside a production.
Yeah, yeah. So from a technical side, it is actually not that different. But the case that we did a couple of years ago with Schmalz is a robotic gripper, and what we did there is to in production to quickly change out the robotic arm or what he has to grip. What we do is we take the mesh of the 3D either scan or the 3D design that may be available. We take this and automatically generate a gripper that can grip the part that you want it to grip. So you add the mass, I believe, and it's almost you push some places on the mesh file, and it automatically generates this gripper. And that for Schmalz, the design time was reduced by, I believe, 90% or so. So they were really happy about that.
So I think I will put the link to the case study into the description because then you get a visual image of it. Because
Yeah,
as far as I saw it, it's like a big arm which
yeah,
has a couple of fingers. I will now call it fingers. And on
yeah.
those fingers, there are small accessories. And this is the gripper, which is then customized to the product it shall grip, right?
Yeah, so in this case, it's suction cups. So it's a suction cup that grabs around the object that it needs to grab. And these suction cups, in this case, the gripper that is attached to the robot arm is automatically generated with the channels for the vacuum already inside. So that's 3D printed inside. And that's also one of the main benefits that they have, that they don't have to have the tubes outside of the gripper, but it's integrated in the 3D print.
Okay. Crazy. So if now like somebody's listening and people have this approach of mass customization, because I mean like mass customization can also be about, because we have been discussing about use cases, can also be about integrating names and numbers and basic things also into standardized designs. So how does it work if I want to include your software into my process, or if I want to build a product based on that, which customers can use via user interface?
So right now you would contact us, and we'll have a couple of developers developing your product for you, and then place it on your website, and then your customers can use it if that's the thing that you want. And what we are testing right now is giving third parties access to our CAD software. And that's what I'm mainly focusing on right now. because the way we have been doing this is scalable to a certain amount, but not scalable in a way that we would like to be scaling. So we want to have other people have access to our CAD system as well
Yeah.
as the front end then. So they can do the development themselves.
Okay. Just out of curiosity, um, uh, very often I have a look on Etsy and I see a lot of metal parts in the accessory area, or like in and like in the fashion area where people are
Mm.
buying some chains or anything. And
Mm-hmm.
I'm quite sure that the majority of this is being printed, and a lot of them are also meanwhile
Mm.
offering customization. Is this also something in the very consumer part? Because especially on Etsy, I see a lot of customization that people do, which is also like a possible application of your software.
Yes, so we've been doing that in the past as well. We've made some hangers for necklaces. We've moved away a little bit from business to consumer products because of other reasons. But in principle, it's actually very possible and very simple to do. It's the low hanging fruits, I would say.
Yeah.
But we wanted to move on from that. But it is still very, very viable, very possible. And I
Yeah.
think if you have this Etsy shop and you want to have something customizable like a necklace, that is super easy to do in our software. Yeah.
Okay, yeah, because I think very often I look into that, and if you see that people just render the images of those, and you see how they designed the item, you can easily see that it will be 3D printed in a metal uh,
Yeah, and for us that doesn't
approach.
matter what kind of 3D printing technique you're
Yeah.
going to use. What we put out is a mesh file that can be 3D printed in whatever way you want to 3D print it.
Okay. Um, all right. I think that was already really great that we understood um, how a normal design process looks like, how it shifts conceptually completely in your approach, what the use cases can be. Let's have a look into the future. I mean, because for example, when I'm building a website, meanwhile, I always use any kind of no code platform. Basically, everything we do is just with some kind of generator. You basically don't have to code for a lot of stuff that's currently being produced. We see a lot of AI tools popping up everywhere where you already even move away from that, and basically we see that there's a big shift in how things are generated and how things are done. So, and I mean, trinckle and like your software is like the same, because for the end user, they don't have to design themselves, but um, you basically give them the opportunity to also generate it based on certain inputs. Um, how do you see that development on the one hand in the design space, um, but also from the point of your of I mean of your software?
Yeah, so the last couple of weeks, months have been really exciting in AI. And I think a lot of companies are waking up and seeing, oh, we have to do something with that. And for us, it's also really exciting. There's not a team meeting that goes by when we're not talking about AI. And we've been doing some tests with it as well. And I think it's really exciting to see, especially because we have a scripted cut software, and the AI we see now is language based. It is actually quite capable of understanding our cut software and generating um, some designs there. We're not quite there yet. it is making still quite some mistakes, but it's very there's a lot of potential there. So we are doing some little tests behind the scenes. I can't say too much about it yet, but it looks very promising indeed.
Okay, but like a prompt input would just be a different version of the current parameter input, right?
Um, I could imagine that would work in the future. Right now, it's not working like that. So right now, you're mainly using it in our CAD part, our CAD part of our software, and not so much in the user interface part, Paramate. But I don't actually see why that needs to be. I mean, it could very well be a parameter as well, I
Yeah.
guess. I mean, we're not quite there yet. That it's not as foolproof as it should be if you want to have your customers be able to not saying that your customers are fools, but it needs to be foolproof
Yeah.
to put out in production.
No, absolutely. And but I mean, at the end of the day, when it comes to whether it's a prompt or whether you're just working with some settings and parameters, at the end of the day, the degree of automation is also increasing then in the design space, because people like me are not sitting there anymore with a CAD software, but if I want to have a certain part and maybe the manufacturer is offering me that customization opportunity, even for doing it myself, I mean, that's a huge form of automation that wouldn't have been possible previously, right?
Um, I mean, we've done our best to make it possible for our customers, but I think AI is accelerating that to a degree that we haven't seen before. Indeed, yeah.
Okay. Like then we also covered the super buzzword AI as well. That's great. No topic today without that. So let's get to the final question, which I always think is like super interesting to see from people who are really into a certain technology niche. And so, what from your perspective is like the development or trend currently, except for AI, people, because it's not underestimated, but are people currently underestimating that you see that all of us currently don't see?
Yeah. So what I think is that AI is getting there, but still something for the near future. What we are doing right now, and what is really exciting is jigs and fixtures in and other production aids. And why this is very exciting is that because many production companies, are nowadays familiar with 3D printing. They use it for their prototyping, and they're kind of looking to the how to do the next step in additive manufacturing. But making that step to actually production ready products is often a too big a step to take. Um, the secret low hanging fruit that we have identified is the jigs and fixtures. And other production aids for producing companies. For example, a case we did for Ford is where we have a production aid to add the logo on the trunk of the car exactly on the same spot every time. So this is a jig that you put on the trunk, and then you can place the logo exactly where you want to. And this is it's not too difficult to understand the design, but it's actually quite a tedious task for a designer to do. So what we want to do is enable the production floor to make their own jigs and fixtures to be able to do production aids.
Okay. So also something that goes deeply into the productivity and time and cost saving part.
Exactly. So the designers are highly skilled workers, and they often don't have the time to do these kind of things for production. So what we want to do is make it a simple and nice interface where anybody can make this jig with minimal knowledge of CAD design.
Nice. All right. I think this is also something I haven't heard before and didn't dive too deep into. So thanks for that. Thanks, Vegter, for taking the time. And yeah, I hope we'll see more and more design automation as soon as possible. So I don't have to learn any new tools.
Yeah, that's exciting time. So I think we are doing some things with Enable 3D as well. So that's it's going to be exciting to see what comes out of that.
Perfect. Thanks so much. Bye bye.
Thank you. Bye bye.